Welcome in the arena. My name is Allison Klein. We're coming to you from OCP Summit in San Jose, and I am delighted to be with Kevin Coakley, CEO of CelLink. Welcome.
Thank you.
So, Kevin, before we even get started, CelLink is a new name for a lot of the people that watch this show. Why don't you go ahead and introduce the company and the background that you and the team have in terms of delivering really innovative technology?
Yeah, thanks for having me. It's great to talk about CelLink with the data center community. CelLink started as a concept for the back of a solar panel. Originally, we set out to figure out how to make solar panels more efficient by moving the wiring from the front to the back of the panel. And when we started developing that technology, we realized that there wasn't an existing solution out there that could transfer the current that you need to transfer inside a solar panel. So we basically invented a new manufacturing technology that enables very high currents to be transmitted with a very flat wiring element. And so that's the value proposition and origin of CelLink.
Now, I know that you've had success in the automotive arena with these core capabilities. Here we are at OCP. The focus point is AI factories. Tell me about why you think this is such a cool capability when you think about the power challenges in AI.
Yeah, well, thanks for the segue, and maybe to complete the origin story, around 2018, we met some folks in the automotive industry, and they said, if you can connect solar cells with your technology, why not battery cells? So the name CelLink actually still applies. And so we mastered how to carry very high current within a battery array in an electric vehicle. And what we see happening now is that the exact same problem is popping up in the data center world, where you need to get very high currents into 0.8 volt GPUs to make them compute. And the challenge becomes, how do you get the power there most efficiently? How do you burn the least amount of watts in the transport of the power? And so that analogy is almost a perfect fit for us as we go from automotive to data centers.
And when you look at what's going on in data centers today, we're talking about gigawatt class facilities, megawatt class racks. How has the design point shifted to open the door for something like CelLink?
Yeah, great question. The higher and higher power usage requirements also come with a stronger space requirement. That these GPU manufacturers and data center manufacturers want to pack their compute into a smaller and smaller footprint, mainly so that they can get the signals from A to B without having the signals get lost. But as you condense that entire rack, you need to deliver even more power into a tight space. And that's where our product comes in, because it's very flat. So all of that precious space that's gobbled up by traditional round wire harnesses can now be replaced with a flat power delivery element that performs the same function but with much less space.
You've worked with some of the largest auto manufacturers on the planet. Tell me a little bit about what that teaches you about starting to engage with some of the largest manufacturers on the planet, those that are delivering compute infrastructure.
Yeah, great question. And the number one word that comes to mind is quality. And getting to automotive quality is a trial by fire. My hair was brown when I started CelLink. It's now gray. And you know, we learned a lot in scaling up this technology for automotive. And I'm happy to say that we've had a lot of success too. We have over 3 million parts in vehicles today.
Impressive.
Yeah. Only 19 have failed. So that's a number I keep etched into my brain because we want that to stay low. But that's an extremely low failure rate for our first, foray into automotive. And now we're planning to transfer that quality knowledge into the server space.
Now, the thin and flexible design I saw it. It's very cool to look at. But tell me about why you think this could be innovative in terms of the entire system design and really the entire rack design for customers.
Well, the product we're launching today is called the PowerPlane, and it integrates power delivery and cooling into a single product.
Wow.
So that you can now...
You just tackled that too, huh?
Yeah. And ironically, the same manufacturing process can be used to make both. So this is not a pivot or a reinvention. This is an extension of what we already do. But because we can combine these things, it allows us to open up what's called backside power delivery into a server architecture. So instead of having to run wires to the top of a motherboard, you can now deliver power from the bottom, and you can cool from the bottom, which opens up the top to be used for signaling only. And so that's a big sort of architectural shift that we enable with this product we call the PowerPlane.